Hello everyone, my name is Shreyas. I'm an educator at an academy. You can follow me on the Learning app where you can see my new set of courses. Also, courses by awesome educators. So please do install the Learning app. So today I'll be taking a lesson about milling. So what is milling? You can see here the placement of these grooves. So these grooves are done by the usage of milling machine. So let's get on with the lesson and please do subscribe our YouTube channel. Thank you. So guys, let's get on with the course Elements of Mechanical Engineering. I've given my intro already. This is my Unacademy user platform. Please do follow me over there. Machine Tools and Operations is our course on which we'll be doing our lesson. So the target audience for this lesson or presentation will be the engineering students, general audience who are interested in mechanical entities, people who are interested in machine related mechanisms, and automobile enthusiasts. So what are the learning outcomes after this presentation will be? You guys will come to know the basic working principle of milling. You guys will come to know the classification of milling, the classification of milling machines, the horizontal milling machines which is in the syllabus of the engineering curriculum, the operations of these horizontal milling machines, the vertical milling machine, and the comparison of horizontal and vertical milling machines. So let's get on with our lesson, milling machines. So let's have a quote before that. Man makes machines to man the machines that make the machines. Hope you guys have understood this quote. So let's get on with the principle of milling. In principle of milling, in milling the workpiece is actually mounted on the machine table. The table, it can slide both horizontally and vertically. The milling cutter is mounted on the machine spindle. The spindle, it receives power from a motor, and hence the cutter rotates about the axis of the spindle in the vertical plane. Based on the requirement, the table or the workpiece is moved against the rotating cutter, and then the designed machining surface is obtained in a single pass of the workpiece. Any desired depth of cut may be obtained by multiple passes of the workpiece. Equally spaced peripheral teeth over the cutter, the teeth which I had shown you in the intro video, over the cutter, it actually intermittently engages and machines the workpiece. This is actually called as interrupted cutting. What does this interrupted cutting help in? It actually enables the cutter teeth to be cooled effectively till they engage the workpiece again, means till the next operation. So this is how the milling works. You can see the tool rotation, the workpiece, and how actually the tool goes around the workpiece. These are the chips which are the unused workpieces which are formed after the workpiece is formed. They are actually vomited out. And the milling machine, the workpiece actually moves and the tool remains stationary. The tool is actually in the same position whereas the workpiece keeps moving. So this is what the milling thing actually does. You can see here grooves and all with the usage of milling. The tool remains stationary whereas the workpiece, it keeps on moving. So this is actually the milling machine which is used in mechanical sectors. So this is actually milling machine where the workpiece is moves over here and the tool remains stationary. And you can see the presence of various buttons also through which various operations can be done on the milling machine. And you can see here this pipe or this coolant area, it produces or it actually protrudes the working fluid on the workpieces, milling machine workpieces. So what is the classification of milling? The peripheral milling. When we call the peripheral milling is when the job surface is parallel to the axis of the rotation cutter. When the job surface is at right angles to the axis of the cutter, we call it as face milling or end milling. When the cutter, it rotates against the direction of the feed or the job, it is called as up milling or conventional milling. And when the cutter rotates in the same direction of the job, it is called as down milling or climb milling. You can see this is the picture representation of peripheral milling, and this is the picture representation of face milling. You can see this is the picture representation of up milling. You can see when the cutter is about to finish its motion, it takes out the workpiece, but here when the cutter is in its motion only, it takes out the workpiece. You can see the feed is actually in this direction, whereas the feed is in here in this is the down milling, this is the up milling. Let's go on to the classification of these milling machines. So the milling machines are classified as follows: horizontal, vertical, universal milling machines, planar milling machines, and special type milling machines. How are these machines? Let's see in the pictures coming forth. So this is actually the horizontal milling machine, which is used in our mechanical sectors. This is actually the vertical milling machine. In the horizontal milling machine, the workpiece actually moves in a horizontal direction, whereas in the vertical milling machine, you can see the workpiece is fed over here and it moves in the vertical direction. Whereas in the horizontal milling machine, the workpiece is fed below this surface. Means the workpiece is fed here, whereas here the workpiece is fed here, just like a lathe headstock. So these are the planar universal milling machines. Universal milling machines is the combination of both horizontal and vertical milling machines. In this universal milling machines, you can actually place the workpiece both horizontally and vertically, and it consists of various speeds and setups which can be done by the usage of this universal milling machine, which are actually lacking in both the horizontal and vertical milling machines. The speed thing, the gearbox. So this is actually the planar milling machines. Planar milling machines are used when you have to mill large area of workpieces in a plane. So you can see here the workpiece area where the workpiece is actually placed is actually very higher or very larger compared to the horizontal and vertical milling machines. Then you have the special type milling machines. This is used for producing high number of gear and pinions on a workpiece. You can see it has a big cylindrical workpiece where production of holes is done. And then you have the milling machine. This milling machine is actually a combination of both drilling and milling machines. Here the milling process happens and here the drill process happens. So this is another type of special type of milling machine. So this is another special type of milling machine where it is used for producing of stepped bars. Stepped bars are produced in this process of milling machine. So let's move on to the horizontal milling machine, which we use in our mechanical sectors. The horizontal milling machine, it actually consists of a base which serves as a foundation member. All the other parts rest on the base. It carries a column at its one end. The column, it houses all the driving mechanisms of the spindle and the table feed. The spindle receives power mainly from the motor. It supports an overarm at its top, which is also called the spindle nose or the knee. The knee is it is supported on an elevated screw and on the guideways on the column. It can be moved up and down like we have seen with the drilling thing. Then the table may be moved up and down, which we already know. Then the table is actually accurately finished with the T-slots to cam the workpiece and other fixtures on it. Why do we need T-slots? To provide the teeth on the workpiece. The saddle, it can also be moved horizontally using the hand wheel, which is engaged to a lead screw. An arbor, which is also called a shaft, is supported between the spindle nose and the yoke of the overarm, and it receives power from the spindle. One hand of the arbor is tapered so as to fit in the spindle nose. The milling counter is actually mounted on this arbor. It is provided with spacers. Why the spacers is provided is the spacers help in the facilitation of the adjustment for the cutter positions. So this is what a horizontal milling machine is, a plain horizontal milling machine. So this is where the workpiece is fed and this is where the fluid is flown through the workpiece, and these are the power switches where you can on and off, and it actually moves horizontally, and here the tool is fed, so how the milling happens. You can see it in any mechanical labs. So what is the operation of this horizontal milling machine is, the workpiece is actually mounted on the table with the help of suitable fixtures. The desired contour, feed and depth of the cut of the job are noted down. It is very simple to the drilling machine itself. A suitable milling cutter for the specified job is selected and it is mounted on the arbor. And then the knee is raised till the cutter when it just touches the workpiece. The machine is then started. By moving the table, saddle and the knee for the specified feed and depth of cut, the desired job may be finished and then the machine can be switched off. So what are the operations on this horizontal milling machine? You have something called as plane milling, which is also called as slab milling. It helps in the production of flat or formed faces which is parallel to the cutter axis. A plane or slab milling cutter has straight or helical teeth which is used in this process. There are two types, namely up and down milling. Up and down milling I have already shown you guys in the starting of this lesson. Then you have something called as slot milling. Slot milling is a process which is used for the production of desired slots, grooves and keyways using different types of cutters. The open slots may also be produced using the plane milling cutter. Then you have something called as angular milling. Angular milling is a process which is used for the production of V blocks and desired angular grooves with the help of a suitable single or double angle cutter. Then you have something called as form milling. Form milling is a process which is used to produce irregular contours which are like concave, convex or any desired shaped grooves or edges using a suitable form cutter, which is milling cutter. Then you have straddle milling. Straddle milling is the process of producing square or hexagonal surfaces vertically on the workpiece using two-side milling cutters. Then you have the milling. Gang milling. Gang milling is a process of machining several surfaces of a workpiece simultaneously at one pass. It consists of a number of desired cutters which is mounted on the same arbor. So you can see the various things. You can see this is actually the plane milling or the slab milling. This is the slot milling process. This is actually the reaming process. And you can see the up milling and down milling process. And you can see this is actually the straddle milling process, as well as this is the straddle milling. This is the gang milling, consists of two things in the same thing. This is actually the angular milling process, production of angular grooves. Then you have the vertical milling machine, which consists of the following construction. The construction is very similar to the horizontal milling machine, but the only thing is the horizontal milling machine has horizontal work space or work feed space, whereas the vertical milling machine has vertical workpiece space. So these are the various things. You can actually calibrate it with the horizontal milling machine. It also consists of a base, column, spindle head, swiveling base, vertical spindle, motor, cutter, knee and a hand wheel. So this is what I was telling about a vertical milling machine. So the operation is similar to the horizontal milling machine. The workpiece is mounted on the table with the help of suitable fixtures. The desired contour, feed and depth for the job are noted down. A suitable milling cutter is actually used for the specified job and it is mounted to the spindle. Both the knee and cutter are moved vertically opposite to each other suitably such that the cutter touches the workpiece. The machine is then started by moving the table, the saddle and the swiveling of the base, the knee for the specified feed, angle and depth of cut. The desired job may be finished. The machine can then be switched off. So let's have a quick comparison of both the horizontal and vertical machines. The spindle position is parallel in the horizontal, parallel to the work table in horizontal machine, whereas it is perpendicular in vertical machines. The spindle movement, it rotates about its own axis, whereas it is swiveled in the vertical milling machines. The motor position is housed in the column in horizontal, whereas it is mounted directly over the spindle head. The cutter position is actually supported on the arbor, whereas in vertical it is mounted directly to the spindle. The cutter movement, it rotates about its own axis, whereas the cutter movement is possible to move up and down. The cutters used in horizontal milling machine are plane milling cutter, side milling cutter and angular milling cutter, whereas in vertical milling it is end milling cutter and slot milling cutter. The operations done on horizontal are peripheral milling, slab milling, slot milling and gear cutting, whereas in vertical milling, face milling and end milling. Gear cutting is what I had shown the word piece in the intro video, so that is what is gear cutting process. So these are the various cutters used in milling machines: the cylindrical, concave, single corner, convex cutter, side and face cutter, single angle cutters and equal angle cutters. So thank you guys. Any questions? Please leave those in the comments box below. And this is my Unacademy user platform. And please do rate the course. review the course and recommend this lesson or presentation if you have liked it. And this is my Unacademy user platform again.